Hello, so here we are trying to learn how to multiply polynomials. Hopefully by this time you've already interacted with how to add and subtract polynomials. So this is the next natural step, is multiplying polynomials. When we are multiplying polynomials, we have another phrase that we can call this, and it can also be known as expanding. So if I say expand these polynomials, that's the same as multiplying. When we multiply polynomials, we use our understanding of the distributive property. So again, it's something we already know. We're just going to use it in a slightly different way. Now, if you remember, the distributive property we used at the very beginning of the school year, and we used that when we had something like 3 times 2x plus 5. And if you remember, what we would do was to get rid of our parentheses, we would take the 3 times 2x to get 6x, and then take 3 times 5 to get plus 15. So that's the same exact skill that we're going to be using when we multiply polynomials. So let's look at an example. It says expand, and remember the word expand really just means multiply. So expand the expressions and write them in standard form. So I have something outside of my parentheses, and I need to multiply it to everything inside my parentheses. Now what's different about this problem than what we've done in the past? Well, when I look at the term that is in front of my parentheses, there is an x there. And in the past, there's never been a variable there. But I promise you it's not very difficult. We're still going to take this 5x times the 6x. So 5 times 6 would give me 30. And then I just have to think about, okay, what is x times x? Well, x times x is going to give me x to the power 2. Then if I take 5x times 7, 5 times 7 is 35. And the x tags along from the outside. And this would be my final expanded answer. Let's look at problem B. On the outside, I have negative 3x to the power 2. And I need to multiply it to everything on the inside. So negative 3 times 7 gives me negative 21. I have an x squared on the outside and an x to the power 5 on the inside. So if I have 2 x's plus 5 more x's, that will give me x to the power 7. Then negative 3 times 3 would give me negative 9. And again, if I have 2 x's out here and 3 right here, that would give me 5 total. And again, I'm going to take this outside term and multiply it to the end. Negative 3 times negative 8 is going to make a positive 24, so I'm using a plus sign, and the x to the power 2 tags along. And this would be my final expanded polynomial. Now, if you haven't caught on yet, whenever I multiply variables together, I simply have to add up their exponents. So, if I have x squared times x to the power 5, that becomes x to the power 7. If I have x squared times x to the power 3, that becomes x to the power 5. I simply add their exponents. Here's a couple more examples. Now in part C, you'll notice that we have 2 sets of parentheses. Now really all we would have to do here is double distribute. I have to take the 4x and distribute it, and I'm going to take the 3 and distribute it. So first let's do the 4x. 4x times 8x squared. 4 times 8 is going to give me 32. And x times an x squared is going to give me x to the power 3. Then I'm going to take 4x times negative 5, which will give me negative 20x. So I've distributed the 4x. But now I also need to distribute the 3. So I'm going to go 3 times 8x to the power 2, which would give me plus 24x squared. Then I'm going to take 3 times negative 5, which would give me negative 15. Now the last thing I have to do is take this equation, or excuse me, polynomial, and rewrite it in standard form. So I'm finding my biggest exponent first and putting that in the front, followed by my next biggest exponent, and so on down the line until I get to my constant. And this would be my final expanded polynomial. Part D is very similar. There are just more terms. In the front set of my parentheses, I still have 2 terms. I have a binomial. So I just need to distribute each term to everything in the other parentheses, or double distribute. So 3x squared sorry, I decided to slide it up a little bit. But I'm going to double distribute. So 3x squared times 9x to the power 7. So 3 times 9 gives me 27. And now I'm going to add the exponent. So 2 plus 7 would give me x to the power 9. And now I need to continue. I need to take 3x squared times 11x to the power 3. So 3 times 11 is going to give me 33. X to the power 2 and x to the power 3, if I add those up, would give me x to the power 5. 3 times negative 8 is going to give me negative 24 x to the power 3. Now I need to distribute my other term. I need to take the negative 4 and distribute to everything in the back parentheses. So negative 4 times 9 would give me negative 36. The x to the power 7 stays behind. Negative 4 times 11 would give me negative 44, x to the power 3. Negative 4 times negative 8x would give me plus 24x. And again, my last step would be to go through and organize so that all of my terms, or so that all of my exponents are in standard form. So put the largest exponent first, followed by the next, Now hopefully you notice something here. As I look through my standard form, I notice that I have 2 terms that have the same exponent. Now the great thing about this is I can use my skills from adding and subtracting, and I can combine these 2 terms to simplify my expression even further. So negative 24 plus negative 44 would give me negative 68 x to the power 3. And all of my other terms are just going to come straight down. And this would be my final simplified and expanded polynomial.